Hello, I'm going to tell you how to establish trigonometric identities. What do you need? You need the basic trigonometric identities, quotient identities, reciprocal identities, Pythagorean identities, even odd identities. And keep in mind the guidelines. Start with the side containing the more complicated expression. Choose the more complicated expression to work first. Rewrite sums or difference of quotients as a single quotient. Try to do additions to get just one quotient. Sometimes rewrite one side in terms of sine and cosine functions only will help. Use sine and cosine as you like. And always keep your goal in mind. Remember that you have to establish the identity. Work in the left side or the right side, taking into account that you want to know which is the other side. We're seeing with an example. Establish the identity. This is the identity we're going to establish. Cosine of b over 1 minus tangent of b plus sine of b over 1 minus cotangent of b equals sine of b plus cosine of b. So you can follow any steps you want, but as long as you're working, sometimes you will choose or prefer other options first. For example, I'm going to use guideline number 3 first. I'm going to rewrite one side in terms of sine and cosine functions because that's going to help me. And I'm going to start with the side containing the more complicated expression. I'm going to work with the left side. Working with the left side. And now I'm going to rewrite denominators in terms of sine and cosine. So let's try the equation. In terms of sine and cosine. Tangent in terms of sine and cosine. Quotient identities. Tangent is sine of the angle divided cosine of the angle. Cotangent is cosine of the angle divided sine of the angle. So let's transform tangent as sine over cosine of the angle, and let's transform cotangent in terms of cosine of the angle divided sine of the angle. Okay, as you could see, this expression, it's pretty difficult to work with in this case, so I'm going to take it away and work with that, and when I finished I will put it again in the term. So I'm gonna move it. Working with denominators only. So the first expression is 1 minus sine of the angle divided cosine of the angle. So I can rewrite this expression, this one, with one common denominator, that is cosine. Cosine of the angle divided, of course, cosine of the angle. And as we have a common denominator, we can write the expression as cosine of b minus sine of b divided cosine of b. That's the first part. Now let's work with the other denominator. Let's work with the other denominator. So we can do exactly the same, but now one is not with cosine but with sine. Sine of b over sine of b. So that's equals to, we're having sine of b minus cosine of b divided sine of b. Now remember the guideline number 4. Always keep your goal in mind. We just work with denominators only. Now we're going back to the equation. We're going back to the equation. And we're going to substitute 1 minus sine of b over cosine of b as cosine of b minus sine of b divided cosine of b, and 1 minus cosine of b divided sine of b, we're going to take it as sine of b minus cosine of b over sine of b Now we have to apply the expression for simplifying the fraction. Simplify the fraction. So remember, to simplify the fraction, outers and inners. So this fraction will be cosine of b times cosine of b, cosine square of b. And denominator will be cosine of b minus sine of b. Same way, sine of b times sine of b, sine square of b, divided sine of b minus cosine of b. If you notice, both denominators are the same, but with a negative sign involved. So I can factor a negative sign to convert sine of b minus cosine of b as cosine of b minus sine of b. So I'm going to factor the negative sign, and denominators will be the same denominator. Same denominator. Now what is next? I have common denominator, so I'm going to apply the property. The property to add rational expressions. Common denominator, so add or subtract numerators. Add or subtract numerators. In this case, it's a subtraction. Cosine square of b minus sine square of b divided cosine of b minus sine of b. And keeping our goal in mind, that's equal to sine of b plus cosine of b. We have two options. First option is to multiply by the common denominator the other side and prove that the identity is established, or the other way is to reduce the fraction to prove that the identity is the same. I'm going to show it by reducing the fraction. How I'm going to reduce the fraction? Numerator could be factored. How? This is a difference of squares. Numerator could be factored by a difference of squares. So difference of squares says a squared minus b squared is a minus b times a plus b. So cosine square of b minus sine square of b will be cosine of b minus sine of b times sine of b plus cosine of b. Look at, here is cosine of b minus sine of b times sine of b plus cosine of b. Excuse me, if we follow the difference of squares formula is cosine of b plus sine of b. Now, as you can notice, I can reduce the fraction by simplifying common factors. Cosine of b minus sine of b is a common factor with cosine of b minus sine of b. So I can simplify this term with this term. If I simplify it, what do I have? I have that cosine of b plus sine of b is equals to sine of b plus cosine of b. And that's completely true, because addition is commutative. It means that we prove the identity. Identity is true. And this is the way that you can establish identities. I hope that you enjoyed this video. If you want to watch it every time to see each step, it doesn't mean that you cannot prove other steps. You can prove any steps you like, but this is one way to establish identities. Thanks for watching.